Hello again, guys. In this lesson, we are going to be talking about functions and graphing. So if you remember from the last lesson, I told you the two big things of algebra, the two big takeaways of algebra 1, are solving equations and graphing equations. Today we're going to get a little bit more into functions and explain a few more things, and then we will also introduce graphing. So a function is a relationship between the output and the input, just like what we said last time. A function is another word for a relation, as you can see in the actual word, and essentially it's just a fancy way of writing the equation. Now, functions primarily are used when we are graphing because of the function notation. As we discussed in the last PowerPoint, this function notation helps us name different graphs. Okay, but the basic definition, all this is saying is if you were to have an equation, you have your input is x, and your output is whatever your answer is. Okay, this is your output. So keep that in mind. Input is whatever variable you're plugging in. Output is your answer, or is f of x itself. This whole f of x, like I said last time, is just another way to write y. So your output is y or f of x. Now, there are two different types of functions. First one we're going to talk about is discrete functions. And a discrete function is just when the points aren't connected. As you can see in this graph, there's a whole bunch of different points, but these points aren't connected. Discrete functions are used when you're trying to plot things that are just events and instances. There really is no connection between the domain and the range. It's just individual events. The main function that we are going to be focusing on is the continuous function. And a continuous function is when you have a line or a smooth curve. It's when the points are connected. Now, there are several different types of continuous function, and this is where algebra starts to pick up and do stuff. Later on in the PowerPoint, we'll get into the different types of graphs and the different types of functions that can create those graphs. But for right now, just remember, continuous functions are connected, discrete functions are not connected. Now, the one way you can tell if a line is a function or not, because not all lines that you can graph are functions, but the one way you can tell is called the vertical line test. You may have heard about this in middle school. What the vertical line test is you start at one side of the coordinate plane and then move across the coordinate plane. Now, as you move across the coordinate plane, this line, that is your graph, should only ever touch your vertical line once. Okay? So this top one is a function. This bottom one is not, because there's a point in which the graph touches the vertical line in more than one spot. If ever this happens, it's not a function, because this point, oops, you can't see that color. This point right here has one x value. Let's just say x is equal to -5. What you can't have in a graph is a -5 that can give you a 2 or a 0 or a 1 if you were to plug it into the equation. If it's going to be a function, if you have an equation, y is equal to, I don't know, we'll use the one from earlier, 2x plus 4, and you plug -5 in here, there has to be only one answer for this 1x in order for it to be a function. And we'll explain that in a minute. But the vertical line test is the way you can see it visually. And here we go. Okay, here it is again. Now, in this first one, it is a function because even though it looks a little weird, as you move the vertical line back and forth, the vertical line only touches the graph in one spot. In the second graph, as you move the vertical line back and forth, you are constantly touching the graph in more than one place. You'll cover these kinds of graphs in the bottom a little bit more when you get into Algebra 2. But for right now, we are going to focus on the functions and the graphs that are functions. Okay. Now, as we talked about in last PowerPoint, there is such a thing as function notation. This function notation is just another fancy way of writing a y. It is the exact same thing. It goes in the exact same place, and it means the exact same thing. The other benefit of function notation, actually there are two benefits. The first benefit we talked about in the last class, where if you were to have a coordinate plane and you were to have several different graphs on your coordinate plane, you could use function notation to name them. That way, you would always know which graph that you're talking about. Okay, so that's the first benefit, kind of keeping things organized and naming them. The second benefit is knowing what your input is. Okay, so if I just have y, this is an equation, and I would need a separate, in order to solve this equation and figure out what y is, I would need a separate little line over here that tells me what x to plug in. With function notation, this x in the parentheses does this job. So whatever that x is the thing that I will be plugging in to the rest of my equation. What I mean by this. In this first line, here's our original equation. This is what we're given. In the second line, you have f of 2. There is now a 2 in the parentheses. What this is telling you to do is that everywhere you see an x in your original equation, you can plug a 2 there now, and then you can solve. Function notation tells us specifically what it wants us to put into the parentheses. Okay? So always remember, anytime you see function notation, it doesn't matter if it's f of x or if it's g of x or h of x, whatever's in the parentheses is what goes into the equation. It's telling you what to put in. All right. Now, there will be different instances where you don't have a graph, but you still can tell whether or not it's a function. Oops. Okay, ignore group work. Now, the way you know something's a function or not, visually, is if it passes the vertical line test. This means that for every x, 1, there is exactly one y. Okay, there's only ever one x going with one y. If ever you were to have a graph that curved and you had your vertical line test, like I said earlier, that means that this x right here goes with two x's, or two y's. So the simple way, if ever you don't have a graph, to figure out if it's a function or not, is to look at your x-coordinates. Is there only one x per point? If ever you have a set of points and there's an x that repeats, it's not a function. If the x's don't repeat, then it is a function. So, for it to be a function, x values cannot repeat. Now, the y values can repeat all they want, okay? The y values, we don't care about them right now. The y values can repeat all they want. The x values are the ones that cannot repeat. So, like in this first example, when we were trying to determine whether or not it's a function, you would check the x's. Do any of the x values repeat? In this instance, none of the x values repeat, and so yes, you have a function. We don't care if the y values repeat. All right, that's okay. They can repeat all they want. It's the x values that have to remain unique. Now for the other two examples. These two examples, you can't really just look at it. They're not a list of coordinates, they're not a list of points, and they're not a picture. So now we got to have another way to tell whether or not things are functions. Well, the first instance that you can pick is to graph them yourself. That's one way. So if I were to do this first one, here's my graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I were to graph this line, y is equal to -8. Well, that means that at all times, y is equal to -8. There is never an instance where the graph is not y is equal to -8. So that means it's equal to -8 there, and here, and here, and here. It's always going to be -8. Okay? So whenever you have y is equal to a number, you get a horizontal line like that. Well, now you can apply the vertical line test to this. And you notice that you can go all the way across this line back and forth. The x's do not repeat. It passes the vertical line test, so yes, it is a function. You can also tell that number 2 is a function because there are no x's. There is no x in that equation. How can the x's repeat if they aren't even there? So again, yes, number 2 is a function. Now for number 3, you can do number 3 in one of two ways. You can either draw a table. Here are my x's, here are my y's, and you can plug in values. So I can ask what happens when x is 0. And then I have 3 times 0 minus 2. Well, that gives me a -2. And you can plot out different x's to see if they repeat. Or, like we did with number 2, you can graph it. So here we go. We have 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. Okay. So here is a more complete picture of our graph. As a brief reminder of how you graph things, remember that this is our y-intercept and that this is our slope. When you are graphing these lines, the slope is y over x, rise over run. So this means I'm going to go up 3 over 1. So if I start at y is equal to -2 down here, this is my y-intercept, -2. Now I'm going to go up 3, 1, 2, 3 over 1 to right there. Now I'm going to do it again, 1, 2, 3 over 1. Okay, you need at least 3 points to plot a graph. 1, 2, 3 over 1. I'm going to put one down here. That way you can see it. Here is our graph. And again, you can do the vertical line test. After which you know that yes, it is a function because it passes the vertical line test. Or you could do the table and just plug and chug values. So, 3 different ways of figuring out whether it's a function. One is looking at the x's. Do the x's repeat? Number 2, is there even an x? In which case, if there isn't an x, then it's going to be a function because the x's can't repeat. And then number 3 is graphing it for yourself or plotting the points. All valid ways. All right, so now that we've discussed functions, we've kind of gotten into graphs. We even did a little bit of a reminder on how to graph things. We'll go into that more in a bit. Let's just start off with some basic facts about graphing to kind of refresh your memory. Okay. These vocabulary words might look familiar. They were on the last page or the last PowerPoint. You need to know these words, especially these 3. These first 3. You're going to be using those first 3 quite a bit. Now, this last one, the line of symmetry. The line of symmetry is the line that cuts a graph perfectly in half. So its example is over here. I'm going to zoom in over here. In this graph, we have a parabola. This graph is called a parabola or a curve. The line of symmetry is the one that goes straight down the middle. And if you were to fold this graph in half, you would have a perfect crease right there in the exact middle of the graph. We'll get into lines of symmetries a bit later when we graph parabolas and quadratic equations. But for right now, just get familiar with the word. All right. If you need more time to write these, pause the video here, but we're going to move on for right now. Okay? Because we got more vocab. Yay! Number 1, positive and negative. Whenever the graph is going up, it's positive. Whenever the graph is going down, it's negative. Seems explanatory, correct? In this one, the graph is going up in this instance over here. Okay, the line is going up, it is going positive, it is increasing, the y's are increasing. This whole graph is referring to the y values. So when your y values are becoming positive, and I'll change colors to match the picture. When your y values are positive or are becoming positive, then it's a positive portion of the graph. When your y values are negative, then it's a negative portion of the graph. Okay, so positive and negative refers to the y values. Next, we have decreasing and increasing. Decreasing and increasing refers to the slant of the line. So imagine that you had a marble. Okay, and the marble is going to roll down this hill. Anytime the marble is going down, it's decreasing. Anytime the marble is rolling up, then it's increasing. And then again, it goes down. Okay. Whenever you're looking for increasing and decreasing parts of the graph, it's important to remember we read from left to right. So that's always how the graph is going to go, from left to right. So if ever you question which way is it going, start at the left and go to the right. Now, down here, maximum and minimum. So minimum is the low point of the graph. Maximum is the high point of the graph. Okay? Maximum and minimums together are called extremas. So the extremas of the graph are the highs and the low points of it. In most of the graphs you've had up until now, well, they were probably just lines, in which case there is no extrema, because it's just going in one direction. There is no high, there is no low, it's extending forever and ever and ever. However, what we're going to go over is oftentimes you have parabolas, in which case you do have a low point. Or you have, as in this graph, this is called a cubed function. So this is actually y is equal to x cubed. You don't need to know that, by the way. But in this graph, you have a bottom and a top. Like there's a part where the graph gets really, really low and then it turns around. And there's a part where the graph gets really, really high and then turns around. Those are called your maximum and minimums and your extremas. All right, moving on. Last bit of vocab is end behavior. Now, end behavior is a topic that you will discuss later in your math career. An important thing to remember when you're talking about graphs is that they often go forever and ever in each direction. Okay, they're lines, they're extending, they're always moving. Unless it's a segment, it never ends. Now, as you get further on to your math career, thinking more of calculus, the question becomes, what is the line doing as it extends forever and ever and ever in that direction? Well, that's the calculus question. The pre-calc question is just, is it increasing or is it decreasing? And the way you answer this question is to look at the x's and the y's. So it's a little hard to read, but this one says that when x decreases, y increases. Okay, so let's look at our graph. This is the negative side of our x values. We have a negative x, a negative 1, a negative 2, a negative 3. So as x becomes negative, the graph is extending into the positive y's, positive 1, positive 2. So as x decreases, y increases. Same thing or similar thing over here. This is the positive side of the x graph. So we have a positive 1, a positive 2, positive 3. So as x is getting bigger, y is getting smaller. Okay? This is how you describe end behavior. You tell what the x's and what the y's are doing. I'm going to leave it right here. If you need a pause to write some stuff or to finish drawing a picture, now would be a good place to pause. But we are going to move on. Oops. And so, of course, it gets a little screwy. So, we are now at the end of the PowerPoint. The only thing left are 2 problems. What I want you to do is copy this problem down somewhere on your notes. There should be a space at the bottom if you're using the guided notes. You're going to draw the picture, and you're going to write the questions. We are going to go over these 2 questions in class. But using your vocab words, I want you to try to answer these questions as best you can. And I will check your notes to see if you did it before class. So here's the first picture. And then here is the second picture. If you need to pause, just go back and pause it. Okay, again, draw the picture. The questions are the exact same. You're going to use the vocab words you've learned and apply them here. So as I said before a few times, we're not really going to have vocab tests, but I'm going to be asking you to use the vocab words. So do you remember what nonlinear and linear is? Do you remember what the symmetry was? Positive and negative. So using the vocab that you've learned in this PowerPoint, answer these questions to the best of your ability, and we will go over them in class. Have a good one, guys.